Class, good morning! Today, I'd like to introduce to you a new student to our class. Yay! Her name is Nikki. Welcome, Nikki. Hello, Miss Evans, and hello, fellow students. I'm so excited to join you on this fine day of learning.
What? Is this girl a human or a weird school-loving robot? I don't like her. Gross.
All right, Nikki, why don't you go choose a seat somewhere? How about over by Drew?
No, Nero to stretch my math muscles! Whoa! Yeah!
Oh, okay. How about over by Petunia?
Sorry, Miss Evans, but I need this chair for my spare flannel collection. How ironic that is.
She can sit by me. Oh, thank you, Walter. You're such a gentleman. Now, class, let's catch Nikki up to speed. What have we learned so far? Math, obviously. What? Yes, but what specifically?
We did math in this class? I don't remember any of that.
Yes, remember? We spent a large part of our last unit looking at linear functions and graphing lines, remember?
Y equals mx plus b! Whoa, math genius! Give me an A, teach! Yeah! Woo!
Excellent, Drew. And today we are going to be graphing systems of equations. Now, a system of equation is a group of two or more equations with the same variable. And a system of linear equations is when the equations are lines.
Miss Evans, you just said system like 5,000,000 times. I don't get it. Like a sprinkler system?
In a way, just as the sprinklers in the system work together, so too do the equations to rain down upon us.
Miss Evans, don't make jokes. It makes you look like 20 years older. So like 80.
What, girl? I make so many good jokes. Oh. Here's an example of a system of equations. They're both lines, correct? So let's graph them. Nikki, how did you learn to graph lines in your old class? Well, I would get it into slope-intercept form so that I can know my slope, which is my M, and my intercept, which is my B, and I can graph that, and then just make my graph. Math is so much fun. Wow, dreams do come true. You're on fire, Nikki. Excellent job. So let's put these two in slope-intercept form. Subtract the 2x from both sides, and we get y equals negative 2x plus 5. Add x to both sides here. We get y equals x plus 2. Now let's graph these. All right, so negative 2x plus 5. Let's go up to 5. 1, 2, 3, 4, 5. Boom! That's our y-intercept. Then we're going to go down 2 over 1. Make our line here. And now our next one. Up 2 over 1. Over 1. Over 1. Now, does anyone remember what this point is called?
It's the intersection, like when two roads cross, which is like my poem I wrote, When Two Roads Cross.
Yes, the intersection point. So what is our intersection point in terms of an ordered pair?
Oh, it's over 1, up 3, 1 comma 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 3.
Drew, I love enthusiasm. Isn't math great? Exactly. Our point is 1, 3. So both of these lines pass through the point 1, 3. So, which means if I plug in 1 to either of these equations, I'll get out 3. So that is our solution to this system.
So 1, 3 is the brolution. What? Joe? Oh yeah. Math genius.
So Miss Evans, is there always one solution to a system of equations? Oh, good question, Walter. I love you. I love math. I love you, math.
Oh, watch out, Walter. Falling due to math excitement is the #1 reason why mathematicians fall. But great question. There are 3 different types that we're going to look at. Our first type is where 2 lines intersect and you have one solution. That is called independent system of equations. All right. Does anyone have a fun way that we can remember that?
Well, we can remember that the intersection and independent both start with I.
Good one, Petunia. I like it.
I know. Whatever. It's pretty funny.
Yeah! Funny stuff!
Oh, isn't it fun we can all laugh together in math class and learn something? Alrighty. So, the second type of graphical solution is when they are coinciding lines. Let's look at this example. So let's put this in y = mx + b form. I'm going to subtract 3x from both sides. And then divide by 6. And we get, once it's simplified, -1/2 x plus 3/2. Now let's do our second one. Subtract 6x from both sides. And then divide by 12, right? Yeah. We get, oh my goodness, that's the same line. Wow. So these 2 equations are the same line. So it's a coinciding line, which means that every point is a solution. So there's not a unique solution. So it's a dependent solution. Could you think of a fun way to remember that?
Yeah, I depend on my bros, and for a bro inciting line, it's dependent. Like I depend on my bros. Yeah.
Broy, I would say that you've gone over your bro puns for the period, but that is an excellent way of remembering it. Bro inciting line, dependent on your bros. I love it.
Thanks, Miss E. You're such a professional teacher. Yeah!
Now hold on. We don't want to go overboard on our bro puns, do we?
Bro way. Look at, I can be a bro too.
Miss Evans, what's the third type of system? I really want to know.
I've known you for like 2 seconds and you already need to leave, Nikki. Ugh, gross.
Now Bethany, don't squish Nikki's enthusiasm for math. I love it. So the third one is, drum roll please.
Whatever.
Drum roll, 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 drum roll.
Is when there are 2 different lines that aren't the same and they don't intersect. What would these lines be called?
Weren't they like parallel or parallel or something weird like that?
Excellent! Parallel lines! Let's look at a system. These two equations are parallel lines because they have the same slope, but they have different y-intercepts, so they're never going to cross. So this type of system, there is no solution at all, and it's called inconsistent. Now, can we think of a fun way to remember that one, class? How about this one? I used to travel on the trains, which take you from journey A to journey B, and on the parallel tracks, and it was always inconsistent, and there was no solution. Is that a good one, Miss Evans? Oh, that's the best thing I've ever heard. I'm so proud of you guys. Mrs. Evans, pull yourself together. You just monologued about trains for like 30 seconds. You didn't like solve some unknown equation on the back of the Statue of Liberty's thigh or something. Weirdo. I'm just so proud of you all. Excellent, now try this one on your own. What type of system is this?
Inconsistent, because they have the same slope, they're parallel, and they never cross. So everyone else got, yeah!
For sure, brah. Inconsistent. What?
Radio Indeedio. That's what I got. That's the answer I'm gonna tweet later, so holla.
Yes!
Yes! Me too, that's what I got. Aren't we just all excellent math students, Miss Evans? That's right, I'm so proud of all of you. It looks like it's time for a math pizza party, yeah!
Come on now, don't forget to say you will. Don't forget to say yeah, 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 yeah. Say you will. Say it right now, baby. Say you will. Come on. Say you will. Say that you will.
Come on now.
Say that you love me. Say that you need me. Say that you want me. You wanna please me. Come on now. Come on now. Come on now. I still remember when you used to be 9 years old. Hey, I was a fool for you from the bottom of my soul. Enough to know, yeah, you wanna leave me, you wanna let me go. I want you to know, I said